Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Triangles and Their Angles. Alright, let's start by talking about how we can classify triangles based on their angles and also based on their side and angle relationships. Starting with an acute triangle. An acute triangle is where all three angles are acute. In case you forgot, acute angles are angles that are less than 90 degrees. So if all three angles are less than 90 degrees, we're going to call that an acute triangle. If it's called an obtuse triangle, then that means there's going to be one obtuse angle and then the other two angles will be acute. So one of the angles is going to be greater than 90 degrees. Now, I just have drawn examples here. Please do not think that all acute triangles are going to have 56 degrees, 44 degrees, and 80 degrees, or every obtuse triangle is going to be 30 degrees, 98 degrees, 52 degrees. That is not always true. These are just examples. But what is always true is what I have typed up underneath each description, or for each description. Right triangles. A right triangle is a triangle that has one right angle, and most of the time you will see that right angle shown as a little square. Sometimes you actually see 90 degrees, but most of the time you will see that square. All right, let's talk about other ways of classifying triangles. Scalene triangle, isosceles triangle, equilateral triangle. A scalene triangle is going to have no congruent sides and no congruent angles. So none of the three sides are going to be the same and none of the three angles are going to be the same at all. If you have a triangle where at least two of the sides are congruent or at least two angles are congruent, actually both is going to be true, then that is an isosceles triangle. Now, let me point out to you here how we use symbolism, little markings on the triangle to show you that we have two congruent sides. If you see two sides, each with a little slash, both sides having a single slash means both of those sides are congruent to each other. And if you see a single arc mark on each of two angles, then that's a way of showing you that those two angles are congruent. Now, we could also call both angles the number of degrees that they are, and if you see that they are the same, then that's another way, obviously, of seeing that they are congruent. And then finally, the much more rare type of triangle, the equilateral triangle, is where all three sides are the same. So if you see a single slash mark on all three sides, that's a way of showing you that all three sides are congruent. And if you see a single arc mark on all three angles, then that's a way of showing you that all three angles are congruent. By the way, I'll tell you right now, if all three angles are congruent for a triangle, that means all three of them will be 60 degrees. How do I know that? Because of something I'm going to teach you at the bottom of this page. But before we get to the bottom, let's go and practice what we just learned. We are going to classify each triangle as either acute, obtuse, or right, one of those three. And then we're going to also classify each triangle as either scalene, isosceles, or equilateral. Why don't I go ahead and do problem number one with you? Okay, so which one is it? Acute, obtuse, or right? Well, we can see two of the angles are acute, but is the third one also acute? No, this one right here is 90 degrees. And remember, if you have one triangle or one angle of the triangle that is 90 degrees, and that is a right angle, which makes it a right triangle. So let's go ahead and write down that word. And then, is it scalene, isosceles, or equilateral? Well, since two angles are exactly the same, that makes it isosceles. You might also notice that this side here has a single slash mark, and this side here has a single slash mark. That is showing you that those two sides that I have highlighted in green for you are congruent to each other. They are the same measure. Further proof that this is an isosceles triangle, because you will have at least two congruent sides and at least two congruent angles. And I went ahead and put a little triangle symbol here to show you that we are talking about a right triangle, not just a right angle, but a right triangle. The left side should really not be any lighter in how I mark it when I make my little triangle symbol. Do you have to write a triangle symbol? Maybe not. But anyway, hit pause, try number 2 and 3 on your own, and then hit play when you're ready to see how you did. Okay, have you already done number 2 and number 3? For the triangle here in the state of Ohio, we can see that we have one angle. That is 110 degrees. That is bigger than 90. That's an obtuse angle. So if you have an obtuse angle, that makes it an obtuse triangle. Are any of those 3 angles the same? No. So that makes it a scale-lean triangle. So an obtuse, scale-lean triangle. And then problem number 3. All 3 angles, all 3 of them, are less than 90 degrees. So that makes this an acute triangle. And since 2 of the angles are both 75 degrees, then that makes it isosceles. You might have also noticed that the left side and the right side did have these little slash marks trying to show you that the left side and the right side are congruent. So further proof that this is an isosceles triangle. By the way, I will tell you right now, isosceles triangles is a very important part of these guided notes. So if you want to go ahead and put a star on the isosceles triangle, feel free to do that, because this is definitely something we need to learn in these guided notes. Okay, how did I know a few minutes ago that if it's an equilateral triangle that all 3 angles would be 60 degrees? Because I know that the sum of the angles for any triangle must always equal 180 degrees, and if all 3 are the same, 180 divided by 3 gives me 60 degrees. This is a rule you need to learn. Sum, meaning adding the 3 angles of any triangle, will equal 180. In fact, if you look back at the very top of the page, 56 plus 44 is 100, plus 80 is 180. 90 plus 98 is 128, plus 52 is 180. 60 plus 30 plus 90 is 180. So this is a thing. This is a rule about angles of any triangle. The 3 angles added together will always equal 180 degrees. And what you can do is you can use that rule to solve for a missing angle. For example, here you can see we do not know the measure of this angle. It's called x degrees. We need to find the value of x. So how do I do this? Well, there's 2 ways you can do it. You could set up an equation where you say the sum of the 3 angles set equals to 180 degrees. So you could say x plus 94 plus 54, boom, this sum of these 3 angles is going to equal 180 degrees, and then add your like terms together, then do inverse operations. The inverse of adding is subtracting, and boom, you get 32 degrees. Now, if you're like Mr. Underkoffler, do I have to write an equation? The answer is no. You could add the 2 angles you know and get 148, and then subtract that from the total, which will always be 180 degrees for the sum of the 3 angles of the triangle, and that will give you the exact same answer. So I really don't care which way you show your work. Although having said that, spoiler alert, eventually you're going to have to get very good at the equation method, because if I have more than one angle that has an x in it, spoiler alert for the last page of the guided notes, then you're going to have to use that equation method. Okay, let's turn the page. Problem number 1. Which of the following angles could be angles of a triangle? Circle all that apply. Well, what do? We just learned that the sum of the angles of a triangle should equal 180 degrees. So a very quick way of checking to see if choice A is a choice we should circle is we're going to add those 3 angles and see what we get. So if you need to use a calculator for this, you may. 35 plus 65 is 100, plus 80 is, ding, 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 180 degrees. And if you get 180 degrees, then yes, these 3 angles could be angles of a triangle. So hit pause, check out choice B, choice C, choice D, choice E, choice F. Show your work. I gave you enough room, I believe, on the paper to show the work. Add their angles, see if it gives you 180 degrees. If it does, then yes, they could be angles of a triangle. So hit pause, do number 1, and then hit play to see if you got them right. Okay, did you already do number 1? If not, better hit pause now. Choice B. If I add those 3 angles together, once again, I get 180 degrees. So yes, choice B is possible 3 angles of a triangle. What about choice C? Nope, they add up to be 90, so sorry, that cannot be 3 angles of a triangle. 60, 60, and 60. Well, we already talked about this. This must be an equilateral triangle. And yes, they add up to be 180 degrees. So choice D could be angles of a triangle. And choice E. Nope, that adds up to 210. Choice F. Nope, that adds up to 190. So goodbye choice F, goodbye choice E. Only A, B, and D could have been 3 angles of a triangle. Okay, problems 2, 3, and 4 are very similar problems to what you saw at the bottom of the previous page, where you could do the equation method, or you could do the method where you just add the 2 angles you know and then subtract from 180. Now, I might throw a curveball at you every once in a while. I could possibly give you a right triangle where there's a right angle, which means 90 degrees, a little square means 90 degrees. Or I could even throw you an isosceles or equilateral triangle where you have 2 congruent angles if it's isosceles or 3 congruent angles if it's equilateral. So keep that in mind. We could throw those into these problems as well. So hit pause now, do 2, 3, and 4, show your work, and when you're done, hit play so you can check to see how you did. Okay, did you already do 2, 3, and 4? If not, you better hit pause now because I'm going to show you the work. I went and did the work where it's not the equation method. If you did the equation method like you saw at the bottom of the previous page, please know it's basically the same kind of work, just shown in the equation style. So I'm not going to bother showing you that here on my screen for numbers 2, 3, and 4, but you could have done that and it's still going to work out. So add the 2 angles we know, 41 and 110. That's going to give us 151 degrees. Subtract from 180 and we get the value of x, and that is 29. Since there was already a degree symbol here, if you want to put a degree symbol in the answer, you may. If you don't want to, I can't technically get too upset since there was already a degree symbol on the X on the diagram. Problem number 3. Do we have the measures of 2 angles? Well, yes, we do. This square means 90 degrees. So 90 plus 27 is going to give us 117. 117 subtracted from 180. You better have the 180 written on the left. Otherwise, if you had it in the opposite order, you would get a negative. Yes, the order of subtraction matters. That would give you 63 for the degree measure of x. By the way, there is an alternate way of showing the work on number 3. And this is an alternate way that only works if it's a right angle. If you have a right angle, then the other 2 measures add up to equal 90. So believe it or not, on this problem, you could have just done 90 minus 27. And that would have also given you the answer of 63. That's an alternate way of doing work that only works if it's a right triangle. And then we get to problem number 4. You're like, Mr. Underkoffler, it didn't give me a right angle, but it only gave me 1 angle measure other than x. Oh, no. Did you notice that this angle here has a single arc and this angle here has a single arc, showing you that those 2 angles are meant to be congruent? Further proof, this side here has a single slash mark and this side here has a single slash mark, trying to show you this is an isosceles triangle. So you can go ahead and get your pencil ready. That means if this angle is 33 degrees and this angle is congruent to it, then this angle is also 33 degrees. So we can take 33 plus 33 or 33 times 2. Either way would be fine. That gives you 66 degrees. Subtract it from 180 and you get the measure of x being 114. Okay, problem number 5 has 3 parts. Part A is to get which type of triangle it is and explain how you know. Part B is to get the perimeter. And in case you forgot what perimeter means adding the side measures together. So this side measure plus this side measure plus this side measure. That will give you perimeter. And finally, it has a part C. So I would like for you to go ahead and do parts A, B, and C right now. Hit pause and then hit play once you're ready to see how you did. Okay, did you already do parts A, B, and C of number 5? If not, hit pause now and try it on your own first. Here we go. This is an isosceles triangle. There's 2 ways that you could have explained. We see that this angle is called X, and this is also called X. You could also see the single arc mark here, and also the matching single arc mark here, showing you that we have 2 angles that are congruent. And yes, I almost accidentally showed this, but there's also a way of proving that there's 2 sides congruent. This side here has a single slash mark. This side here has a single tick mark, slash mark, whatever you want to call it. Showing you both of those sides are congruent. So I don't care which way you explain it. You could write both if you want. We have 2 sides congruent, 2 angles congruent. This is an isosceles triangle. And now that you know that, you can find the perimeter. We have 60, 25. Ooh, what would be this third side? Every triangle has 3 sides, not just 2. 60 centimeters. So if you add those 3 measures together, and if you want to do 60 times 2, fine with me, that's going to give you 145 centimeters. Notice I'm not even looking at the angles for perimeter. Perimeter is sides of a triangle. Now, having said that, choice or part C is talking about angles. How do I know it's talking about angles? Because it says Y, and Y is an angle. Do you see the degree symbol here? That is talking about that angle in this corner here. So that's an angle. And then it's talking about X. X is, well, measures of angles. This angle here and this angle here. So we are talking about angles on part C. So don't cross this out, but ignore the side measures when you're doing a problem on angles. Ignore them. If you didn't know that and you need to redo part C, then feel free to hit pause now and redo part C. Okay, how do I get the value of X? Well, 2 options. I could write an equation. I know that X plus the other X plus the Y would equal 180 degrees, but instead of writing down plus Y, I know Y is 24 degrees, so I can go ahead and use that instead of saying the Y. So X plus 24 equals 180. Now, how can I solve this? I can go ahead and add my like terms together. And then 2x and 24, they are not like terms, so don't you dare add them together. But you can use inverse operations. The inverse of adding by 24 is subtracting by 24. That's going to give me 156. The inverse of multiplying by 2 is dividing by 2, and that's going to give me finally my value of X. Now, did I have to use an equation? No. I could have started by taking 24 and subtracting it away from 180, give me 156. And then since 2 angles, X and the other X, end up equaling the sum of 156, I could divide by 2, and I get the value of 1 of those X's instead of 2 of those X's. Do I personally care which way you showed your work? No, I do not. Having said that, the equation way is going to be really helpful on the next page. Go ahead and turn to the next page. You will see exactly why. Because, check it out, we now have problems where there is more than one angle that is unknown. Here we got X, here we got 9x, and here we got 14x. This is a unique problem. All 3 angles are called something x. And what do the directions want me to do? They want me to find the measures of the angles. That means all 3 angles measures, because there's an S here and there's an S here. So it's not just one answer they're looking for. They want all 3 of them. So what do? I set up an equation. This angle, x, plus this angle, 9x, plus this angle, 14x. The sum of those three angles equals 180. Since all three of them have x, they are like terms, and I can add them together to get 24x. Please remember, x is the same as 1x. So 1x plus 9x is 10x, plus 14x is 24x. Inverse of multiplying is dividing. That gives me the answer of x. Now, x is one of the angles on this triangle. 9x is this angle, and 14x is that angle. So here's what I did. If x is equal to 7.5, then 9x, which means 9 times x, will be 9 times 7.5. So in my calculator, I do 9 times 7.5, and boom, I have the answer for 9x, which is 67.5 degrees. And yes, you can have decimals, totally allowed. You could even have mixed numbers. And then I'm not done. I need 14x. So 14x would be 14 times x. I know x is 7.5, so that's 14 times 7.5. Again, use my calculator, and I get 105 degrees. By the way, the three angles measures should add up to be 180. And if you take 7.5 plus 67.5, that is going to give you 75, plus 105 gives you 180, proving that I have three answers that make sense. These could be three angles of a triangle. Why don't we go ahead and try number 2 on, or together, actually. What do we got here? Three angles, 5x, 7x. Ooh, the 84 does not have an x. So, who are the like terms? On this problem, unlike number 1, it is only the 5x and the 7x. So that's going to add up to give you 12x. Okay, let's solve. Do not add unlike terms. Do not make this become 96x. That would be horrible. That would be wrong. Let's do inverse operations. We got multiplication. We got addition. Let's reverse that. Inverse of adding, boom, is subtracting. You're writing this down. 180 minus 84 is going to give you 96. And then the inverse of multiplying by 12 is dividing by 12. What does that give us? 8. Am I done? No. The direction said find the measures of the angles. Well, is this one of my answers? Look back at the original drawing. We need three angles from the drawing. We need 5x, we need 7x, and we need, this one we already have, don't we? That one's going to be really easy. 84 is 84. But notice, none of these three angles is only called x. So do not circle this as one of the three angles. It is not one of the three angles. It was on problem number 1. Here it is. X was one of the three angles. But on problem number 2, none of these three angles are only called x. So what do I do? Well, I need the 5x, I need the 7x, and I need 84. How do I get this? Well, 5x means 5 times x. X we now know is 8. So 5 times 8, boom, 40 degrees. What about 7x? Does that mean 7 times 40? No, it means 7 times x, and x was 8. So what's 7 times 8? 56. And then, do I do 84 times 8? Do you see an x here next to the 84? I don't. So 84 is just 84. I know, that's kind of silly, but it's actually not silly because there's no x there, so there's no multiplication involved with the 84. And by the way, let's check. Will these three answers make sense? One way of finding out, add them together and see if you get 180. And it just so happens 40 plus 56 is 96. 96 plus 84 is 180 degrees. So yes, it checks out. Our three angle measures do add up to equal 180, which is good. They better do that for the angles of a triangle. Do not circle the x equals 8. Again, I can't emphasize that enough. If x is not one of the angles on the drawing, then you do not circle the x equals answer. You do not. Okay, hit pause and try number 3 on your own. In fact, I bet that you could also look at how I did number 4. Now, number 4 was a word problem talking about the ratio as 5, 6 to 7. But if you look at my work, you can see how I handled that. And this is really not that hard to do. So I bet that not only could you try number 3 on your own, you should be able to do 5 and 6 on your own as well. So hit pause now, finish up this page, do 3, do 5 and 6, and then hit play when you are ready to see how you did. Okay, did you already do 3, 5, and 6? You better have, otherwise you better hit pause now, because here we go. We are going to add x plus 2x plus 18, set it equal to 180. The x is really the same as 1x, and 1x plus 2x is 3x. This is going to be solved very similar to number 2. Subtract by 18. On both sides, you get 162. Divide by 3. That's going to give you 54. Now wait, you're like, Underkoffler, why'd you circle it? I thought you said we don't circle x. Here's what I said earlier. If x is not one of the 3 angles on the triangle, then you don't circle the x equals answer. But if x is one of the 3 angles listed on the drawing, then x is one of the angles. So who else do I need? Well, I need 2x and I need 18. So 2x and 18. How do I get 2x? Well, 2x means 2 times x. I now know that x is 54. So 2 times 54 gives you 108 degrees. And finally, what about the 18 degrees? Oh, is there an x there? No. So 18 is just 18. Do those 3 answers add up to equal 180? Well, you can try in a calculator right now. And yes, they do. Okay, how about numbers 5 and 6? The ratio of the 3 angles was 1 to 1 to 23. So that means 1x plus 1x plus 23x is going to equal 180. All of them have x, so we can add them all together, get 25x. Divide by 25, that's going to give you x equals 7.2, but the directions said find the measures, plural, of the angles, plural. Back up here, since we had 5x, 6x, and 7x, I need all 3 of those answers. So 5 times x, 6 times x, 7 times x. So we're going to do that here. Now, instead of saying 1x, I can just call it x. And I can do the same thing for the next 1x. The next 1x is also just x. So yes, I have to write them both because they both represent a different angle on the triangle. And then finally, we need 23x. So 23x means 23 times x, 23 times 7.2, and that's going to give you 165.6 degrees. And if you add these 3 angles together, voila, you get 180 degrees. Problem number 6. The 3 measures are in the ratio of 8 to 9 to 10, so 8x, 9x, and 10x adds up to equal 180. They are all like terms. Divide by 27, and you get 6.6 repeating. Wait a minute. Is that going to be easy to do in a calculator? No. Please do not think that if it's 6.6 repeating, that you can just type in 6.6. I got news for you. You can't. It is not the same as 6.6. Yes, it matters. You can't just do a rounded version. So, it would be much better to realize that 0.6 repeating is the same as 2/3. When I taught this lesson in 2024 to 2025 school year, I gave my students a pink paper on common fractions and their decimal equivalents, and it just so happens 0.6 repeating, being 2/3, is on that list. So yes, you should know that 0.3 repeating is 1/3 and 0.6 repeating is 2/3. So when you do 8x and 9x and 10x, it would be so much better to do 8 times 6 and 2/3 than it would be to try to type in 8 times 6.6666666666666. Now, I've seen some kids do it, and they get really close to getting a 53.33333333, except the very last digit might be a little bit different because, again, you're not you can't really do a repeating decimal when you type it into a calculator. So it's much better to use 6 2/3 for your value of x. Here are your 3 answers if you actually did this properly and didn't just type in 6.6 when you multiplied it to 8 and to 9 and to 10. And yes, these 3 measures would add up together to equal 180. Okay, almost done. There is kind of like a part B at the bottom. Is the triangle scalene or is it isosceles? Well, if you have 2 angle measures that are the same, then that makes it isosceles. But if all 3 measures are different, then that makes it scalene. And that concludes the guided notes on triangles and their angles. Thanks for watching. We'll see you next time.